Hi all. I would just want to have you, if you're having a need to see some more specific examples of writing a recursive equation in an arithmetic sequence, this is the video for you. All right, so I just want to remind everybody that this is the same as the slope-intercept form. You actually have already done this, but I do think this is a good time for review. So I'm going to take this a little bit slower. I'm going to go through an example with you, and then I'm going to talk to you about how you transfer that over to an explicit equation for an arithmetic sequence. All right, so step one. Take the terms in the arithmetic sequence and put them into a table. I think that just makes things a little bit more clear. I think when you get used to this, though, you won't have to do that. But for now, I think that's a good choice. If you look at the first column, n, that stands for the term number. But that's just like x in the slope-intercept form. That's the independent variable. And then if you look at the second column, that is t of n. Yes, that is function notation. But in terms of slope-intercept form, that is y, the dependent variable, right? So we're going to actually review slope-intercept form and then transfer that onto basically a recursive, an explicit equation using the format for a sequence. All right, note the arrow. I should be pointing to the 0. I want you to note that I purposefully found t of 0. It says in the instructions that 5 is t of 1, but I found 0 because if you know 0, you automatically know the y-intercept. All right, so I'm going to tell you this right now, but then I'll go into it a little bit more later. I can tell just by looking at this table that the y-intercept is 2 because basically the line crosses the y-axis when x is 0. So in terms of this, t of 0 is going to be the y-intercept. I also know the slope. The slope in this case is the sequence generator, which is 3. The slope is what happens every time x increases by 1. So you can see right from this table, every time x, or in this case n, goes up by 1, t of n, or y, increases by 3. So the slope is 3. All right, but I go into some more details in the next slide, so pay attention to this. All right, and then I'll come back to how I just could tell that from the table as we go along. All right, so if you're trying to get the equation, the first thing you do is determine the slope, right? And I found it just by looking at the table. If your independent variable is going up by 1, it's just whatever your dependent variable is going up by. But right down here, maybe this looks a little bit more familiar to you. Slope is also delta y over delta x. We also refer to it as rise over run. Or sometimes people say it's y2 minus y1 over x2 minus x1. To do this, you just need to have 2 points. And I decided to choose 1, 5 and 2, 8. Right? So for my changes in y, I did 8 minus 5. So 8 minus 5. Now, whatever point with you start on the y's, you must start with the same one on the x's. So since I started with the 8, I must start with the 2 for the x's. So for the x's, it's 2 minus 1 right here. So then you can see when you do the arithmetic here, it's 3 over 1, which is 3. So my slope is 3. That's how you get it from 2 points. So that's another way to do it. All right, third step is to determine the y-intercept. That would be where it crosses the y-axis. Now, one thing you could do here is just go to Desmos Graphing Calculator, and you could graph these points here, put it in a table, and then just see for yourself, where does it cross the y-axis? In this case, it would be pretty clear that it crosses the y-axis at 2. Again, in this case, I purposefully found the 0, though, so I know that it is 2. All right, but let's say you don't know. Here's another way to do it. Plug in the value for m, which we just found out was 3, right? And then choose a point and plug the y and the x in. right, so in this case, I chose the point 1, 5. My y is 5 and my x is 1. So I have 5 equals 3 times 1 plus b, right? I did the math out. I basically am subtracting 3 from both sides, and I end up here with b is equal to 2. Note that came out to be the same as what we had in the table. All right, last step. Here we go. Just take the format for the slope-intercept method, and you plug in the slope and the y-intercept. Right? We have the slope as 3 and the y-intercept as 2. So our equation for this line is y equals 3x plus 2. Right? We'll take a look right here at how similar this is. This equation down here, which is used for sequences, is the slope-intercept form. All I did was put t of n in for y and n in for x. So my explicit equation for the sequence that we started with is t of n is equal to 3n plus 2. All right, that's a little review of that. If you're still stuck, please do not hesitate to email me. My email address is ebailey@rsu14.org. All right, thank you, everybody. I hope this helped.